Okay, guys, I'm really irritated because I just videoed for a really long time and something happened where it stopped recording. Okay, we should be good. I'm going to go through this really fast, so pause where you need to. Expected value and standard deviation. That's the main thing you need to get through. I have two definitions. I don't really find the need to talk about it for a long time, so just pause and get those down. What a random variable is and the probability distribution. I'll talk about it in the problem with the NHL. So I'm going to get going right there with the NHL. In the NHL, I'm going to summarize what this means. So there was 1,319 games. What they did is they put them all in a hat. They shook it up. They randomly pulled the games out, right? They did this over and over and over again. When they pulled a certain game out, then what they did is they randomly chose one of the teams. So in hockey, there's two teams playing. They randomly chose one of those teams and they recorded the number of goals scored by a randomly selected team in a randomly selected game. So this X is our random variable. And then we have all the different options that happened when they did that and the probability of that taking place. Okay, so we have the probability distribution. We have the sample space here and the probability of that happening. The first thing you need to be able to do is to talk about why is a probability distribution legitimate. I have two things written over here. Pause and write these down over here on the side, and then I'll talk about them. What number one means is this means the sum of the probability distribution has to equal 1. You do need to show some work. It's annoying to write every single observation out, so just start with 0.061 plus 0.154 plus ... means you keep going, plus 0.001. This is okay with the College Board to do this. Next, number two, you need to just talk about that each individual probability can be 0 or 1 or anywhere in between, but it cannot be over 1 and it cannot be a negative number. Okay. Moving on, I'm super happy. Make a histogram of the probability distribution. Describe what you see. I didn't do the whole thing. I just started it for you. You can pause it here in a second, but let me describe first what I did. Your x-axis will always be the random variable. So that's x equals the number of goals there. The y-axis will always be the probability. Decide your scale. I decided to go by 200ths. So 0.02, 0.04, 0.06. The histogram of a probability distribution is a little bit of a mix of a bar graph and a histogram. The bars are touching, but there's no like 0 to 1. This whole bar is just 0. This whole bar is just 1. So that's what makes it feel like a bar graph. So for 0 goals, I went up and I look at 0 and I see 0.061. So I go approximately where 0.061 is. And then I just repeat for each observation. Comment on the shape. That shouldn't be unusual for you. It's either symmetric, skewed left, or skewed right. If there's anything unusual. And then the center and the spread are the expected value and the standard deviation of the distribution, which I'm going to show you on the next slide. But first, in part C, it says what's the probability that a randomly selected team in a randomly selected game is at least 6. And how we do that is we go up to the distribution. At least 6 is 6, 7, 8, or 9. So we add across 0.041 plus 0.015 plus 0.004 plus 0.001. Please do that now for part C. Pause it, show your work, and get the answer. Now we're going to go on and we're going to say, well, how do we know what the center and the spread are? That's the next page. Part D. Okay, so hold on real quick. Compute the mean of the random variable x and interpret the value in context. Okay, this is a big deal. I see it every year on the free response questions. The expected value, this is a formula on your formula sheet. Let me describe it. E of x means the expected value for your random variable x, which is equal to the average of that distribution. How do we find it? We need to find the sum of a bunch of products. Products means we're going to multiply. We're going to multiply our observations times the probability of those observations. Okay, let me show you now. So I started it for us. You can watch and then write or pause throughout. You figure it out how it works best for you. To show your work, we're going to say E of x, so the expected value of x. I don't care if you put that little mu there. That doesn't matter to me, and it doesn't matter to the College Board. I'm going to take my first observation. That's 0. So right here. Times the probability of that observation right here, 0.061. So 0 times 0.061. Now plus, that's the sum, times the next, plus the next product, excuse me. So the next product is 1 times 0.154. I would do it again, plus 2 times 0.228. But that's a lot to write out. So I'm just going to write dot, 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 plus the last observation, times the probability of that observation. That's how I shall work for expected value. And expected value is the mean of a random variable. Okay? Let me show you how to do it in your calculator now. In your calculator, you're going to hit Stat. You're going to hit Edit. And in L1, you're going to enter all of the games. I'm sorry, not the games, but the goals. And in L2, you're going to enter the probability of those goals. So pause and do that now. Next, you're going to hit Stat, and you're going to arrow over to Calc, one variable statistics, and in your list, it's L1, and in your frequency list, it's L2. You're then going to go down and calculate. Our X bar is our mean, okay? This is the expected value of the distribution, or the mean of the random variable there, okay? Right here, you notice Sx is blank. It will always be that way if you've done it right. Sigma x now is your standard deviation, 1.6324. Write those numbers down, and then we're going to talk about it and interpret it. All right, give me a second to get back. And I'm back. Okay, if you have the old calculator, look over here real quick. You're going to hit one variable stats, enter, okay? But then you need L1, L2 after it in order to get this expected value. So we have our expected value of 2.851, and part of the goal is we need to interpret it. Here's just a basic frame for interpreting any mean of a random variable x, okay? In the long run, we would expect, put your context, that's the story behind the numbers, an average of about blank. Pause and write that down. And now look, and you can see I've done it in context. In the long run, we would expect the number of goals scored by a randomly selected team in a randomly selected game would be an average of about 2.851 goals. All right, now it says compute and interpret the standard deviation of a random variable x. Now I have a bunch of work here. Ignore my work. Let me explain it first. They don't give you the standard deviation. They give you the variance in the formula sheet, and variance is equal to the standard deviation squared. You can see that there. And what they want you to do to compute that is they want you to take a bunch of sums again, okay? So they want you to add up a lot of things. We take the sum of our observation minus the mean of the distribution. We square it, and we multiply it times the probability of that observation. So I take my first observation. My first observation is 0 goals. That's that right there. Minus the mean, which I found up here, 2.851. I square it. This is calculators or typewriter speak for square. And I multiply it by 0.061. This is the probability of 0. So look up here again. I took 0. I subtract 2.851. I square it. And I multiply it by 0.061. I do it again. Look here. My next observation is 1 goal. Minus 0.2851, my mean. I square it right there. Times 0.154. Where does that 0.154 come from? That's the probability of 1 goal. Plus dot, dot, dot. I continue it, okay? Then I take 9. That's my last observation. And I should have another little plus in here just to be technical. Let me do that real quick. 9 is my last observation, minus the mean of the distribution, 2.851. So 9 minus 2.851. Square it. You can see the square there. Times the probability of 9. Finally, what I need to do is I need to make a square root over it. So I'm going to put the square root of all of this. Wow, that's really messy, but you get the hint. And we got 1.6324. So part of the goal is not only can I find the standard deviation, but can I interpret it? And here's a basic sentence frame for you to interpret it. In the long run, tell the story will differ from the mean by an average of about blank. Pause it, write it down. And now we can do it in context of this story. The standard deviation is 1.6324, which means in the long run, a randomly selected team's number of goals in a randomly selected game will differ from the mean by an average of about 1.6324 goals. Okay, moving on. At a carnival game, okay, we're going to talk about this one. And now, how does this change? I'm not trying to be redundant, but how this changes, we have to write our own probability distribution first. So I'm not going to go through everything with you. I'm just going to write that probability distribution. In order to write that probability distribution, I need to figure out what x is equal to first and look at the question for help. So if you go to the last sentence or question, it says the carnival owner wants to know the average expected payout for this game and the amount of variability. So x is equal to the payout for the game. That's what the question is about. Number 2, we need to actually come up with the distribution. So when I come up with the distribution, I'm going to think about x and then the probability of that happening. So what is x? Well, that's the payout. That's how much the people are going to pay out. So the carnival owners are either going to pay out $20, $10, $5, or nothing. So that's right there. Next, we have to figure out the probability. So you have to use what you learned from our probability units at the beginning of the year to figure these out. It's usually pretty basic, but I'll help you if it gets too difficult. The probability of $20 would be 1 sector out of 60 total sectors. So that's 1 out of 60. Then 2 out of 60, 3 out of 60, and 54 out of 60. Now, there's only 4 observations. I don't know if I would waste my time putting in L1 and L2 when I could just type it all in my calculator once. There's my expected value. I'm not going to do this any further. You can practice the expected value and the standard deviation on your own and then check it with me. It's just extra practice. Kind of like I say, you can never shoot too many free throws. Example 3 changes just a little bit. It talks about the expected winnings instead. So now if you have to pay $1 and you win $20, you truly haven't won $20. Because you paid $1, you only won $19. Then you won $9, $4, and -1. So it talks about the change of this. And we're going to talk more about this kind of stuff on Wednesday. But again, here's just another opportunity for you to practice on your own. The last thing I want to talk about is the difference between a discrete versus a continuous random variable. I stole this image from the internet, and I think it's a nice image. We're dealing with quantitative variables here. And there's 2 types. They're either going to be discrete or continuous. Now, the first examples that we did were discrete. The number of hockey goals that you score is discrete. Why? It's concrete. It's either 0 goals, 1 goal, 2 goals, 3 goals, 4 goals. There can be nothing in between 3 and 4 goals. There's nothing in between 4 and 5 goals. You can't score 5.5 goals. You can't score 6.7 goals. It is very concrete. There's nothing in between. The same thing goes for here when you're winning. I can't win $15 in this game on one roll. Yes, I could win $10 one time and $5 another time, but for one play, there's nothing in between 20 and 10. There's nothing between 5 and 0. I can't win $4. Okay, I can't win $4.50. This is discrete. Continuous is more like running track. Your friend might be able to run the 100-yard dash in 10 seconds. You can run it in 11 seconds. You can find a bunch of people who can run it anywhere between 10 and 11. 10.2, 10.227, 10.3, 10.5978. There are almost infinite values between 10 seconds and 11 seconds, reasonably speaking, okay? And that's what this is saying. Discrete variables are characterized by gaps or interruptions in the values, where continuous aren't. There can be values in between that. Here's some example. I'm 5'7". My sister's 5'10". I can find lots of people in between even 5'7" and 5'8". 5'7" and a half, 5'7" and 3/16, 5'7" and 25/28, whatever. You get the hint. There's lots of things in between 5'7" and 5'8", or 5'7" and 5'9". Where if I talk about going to the hospital, I can only sell 1 admission to a hospital, 2 admissions. I can't sell 2.5. Okay? So you can read more about this if you'd like. You have the cutout, you have this image. Now, oftentimes, continuous random variables are normal, and it will state that. So I have number 23 here, and let's talk about it. The normal distribution with a mean of 6.8 and a standard deviation of 1.6 for Iowa test of basic skills, vocabulary scores, okay, for 7th grade students in Gary, Indiana. Call the score of a randomly chosen student X for short. Find the probability that a randomly selected student will have a score of 9 or greater than that. Find and interpret this result. Step 1, find that z-score, 1.38. Step 2, go to the calculator or go to the table. If you go to the calculator, you'll be able to calculate right away. It's 0.0838. If you go to the table, you have to go to 1.38, and then you have to subtract from 1 because it's greater than. Either way, when we're going to interpret this, give me a second here. We're going to say the proportion the proportion of randomly chosen students that will have a score of 9 or more is equal to about 0.0838. Or you could say there's an 8.38% chance that a randomly chosen student will have a score of 9 or better. Okay. What should you have gotten from all of this? You should understand what an expected value is, how to find it, how to interpret it. A standard deviation as well. You should understand what a probability distribution is. It's showing all the different options. And then the probability is taking place, the probabilities of those options. Finally, you should understand the difference between a continuous and a discrete random variable, and that a continuous random variable most likely will be using the normal distribution. So you'll be finding a z-score and then getting a probability from the table or the calculator. Your to-do now in the next 2 days in class is a 6.1a homework, 6.1b homework, and a check your understanding on Schoology, as well as ask me for any questions. This is all due by Wednesday of this next week, which is November 14th. Have a great weekend, everyone.